Today we're going to talk about functions. All right, so like always, we're going to start here as your state standards and your success criteria. So what do we need to know to be successful today? You need to be able to determine whether a relation is a function. You need to be able to find the domain and range of a function, and you need to be able to distinguish between independent and dependent variables. Recognize the domain, range, independent variables, and dependent variables of geometric formulas that are functions. All right, let's talk about some important vocabulary. All right, a relation pairs inputs with outputs. When a relation is given as ordered pairs, the x coordinates are inputs and the y coordinates are outputs. A function is a relation that pairs each input with exactly one output. Basically, every x is unique. Your domain. The domain of a function is the set of all possible input values. So that would be all of your x values if you have an ordered pair with x's and y's. And the range of a function is the set of all possible output values, so all of your y's. The independent variable is the variable that represents the input values of the function. So if you're using x and y's, if you're using ordered pairs, this would be your x again, or your x's. And the dependent variable is the variable that represents the output value of the function. All right, the output value would be the y's again. And if you look back up here, when a relation is given as ordered pairs, the x coordinates are the inputs, okay? Same thing right here. And the y coordinates are the outputs. All right, so these definitions are very important with this lesson. If you are taking notes, they would be good to have in your notes. All right, let's look at a couple examples. All right, determine whether each relation is a function. All right, so to determine whether it's a function, we need to look at the x values. If all the x's are unique, if all the x's are different, that means it is a function. So A part, -2, -1, 0, 1, 2. Those are all unique. So this one is a function. All right, B part, 4, 8, 6, 4, 5. So you can see the 4s are highlighted. The 4 shows up twice as an input. So that means it has two x values that are the same. So B part would not be a function. So B part is not a function because the x's repeat. All right, C part, -2, -1, 0, 0, 1, 2. Again, it has two x's that repeat. We have 0 and 0 that shows up twice. So C part would be not a function. All right, so A and B is ordered pairs. You look at the x values of the ordered pairs. C part is a table, so you look at the input or the x value. Again, same thing. These would be ordered pairs. It's just written as a table instead. And D part is a mapping diagram. So it has your inputs and your outputs in on separate sides. So again, we're looking to see that our x's or our inputs are unique. So if you look at this, it would be -1, 4, 3, 15, and 11, 15. Because the input values are unique, it only maps from one number to something else. Even though 3 and 11 both go to 15, the input values are unique, so D part would be, yes, a function. So as you can see, the output or the y values, they can repeat. But to determine whether something is a function or not, you only need to look at the x values or the input values. All right, self-assessment. Take a minute, pause the video, and see if you can determine whether these are a function or not. Once you take a second to answer these 5 questions, then come back and we will answer them together. All right, if you took a minute to look at these, hopefully for number 1, you put not a function or no. Determine whether the relation is a function. No, this one is not. Explain. It has 2 5s for input values, so the x's repeat, so it's not a function. Number 2, -4, -1, 2, 5. Yes, this one is a function because all the x's are unique. Number 3, 2, 4, 6. Yes, this one is a function. And you can see you don't even really have to look at the y values or the output. And number 4, 1/2 goes to -1/2 goes to -2, 1/2 goes to 0, and 1/2 goes to 4. So if you had these as ordered pairs, 3 x values would show up as 1/2. So no, this is not a function because the x's repeat. All right, open-ended. This one is up to you. Open-ended means there are lots of different answers. You just have to write one that makes this a true statement. So write a relation that is not a function. So any set of ordered pairs, any table or any mapping diagram that has x's that repeat would make this not a function. How can you change the relation so that it is a function? All right, eliminate some to where all your x's are unique, and that would make it true. All right, key idea. All right, your vertical line test. All right, still talking about functions. This is an important way to determine whether something is a function or not. All right, so in words, a graph represents a function when no vertical line passes through more than one point on the graph. All right, examples. All right, this is just points, but it's like ordered pairs. This would be an xy, this would be an xy, and xy. Each one of those is just a set of ordered pairs. You can see that the vertical line test would pass through each of these points only one time. So they would only have x's show up one time. Here, this is not a function. Okay, this is a continuous line, but you also could have just points doing the same thing. But because this x is on top of this x, so if you graph this line, every x on this imaginary dotted line here, it's not imaginary because you can see it, but this is just representing your vertical line that you can slide. You can call it the pencil test, any vertical object that you can use that you can slide across a set of ordered pairs or a graph to determine whether it's a function or not can be used. And you can see that this point and this point are both have the same x values. So this one would be a function, this one would not be a function. All right, so use the vertical line test to determine whether each represents a function. All right, if I use the pencil test, I'm going to see that if I go across, I'm going to have 2 points that have an x value of 2 and 2 points that have an x value of 5. So there are 2 reasons this one is not a function. It only needs 1 to show up twice to not be a function, but this one has 2 reasons to not be a function. So A is not a function because it does not pass the vertical line test. B is a diagonal line, so each x shows up one time, so B part would pass the vertical line test, so B part is a function. All right, the next part says self-assessment, so again, pause the video and see if you can determine if 7 through 12 represent a function using the vertical line test. When you finish, unpause the video and we will answer these together. All right, hopefully you had time to do these and you can see that this one is not a function because it has x's that repeat. This one is, yes, it is a function because the x's do not repeat. Number 9 is a function because the x's do not repeat. This one passes the vertical line test, so x's do not repeat, so yes, it is a function. It's a circle, so it will not be a function because it does have multiple places where the x's repeat. So number 11 is not a function Number 12 passes the vertical line test, so yes, it is a function. All right, example 3, key idea, domain and range of a function. The domain of a function is the set of all possible input values, so all your x values, and the range of a function is the set of all possible output values, or your y values. So it says find the domain and range of the function represented by the graph. So you can look at each point on a graph as an ordered pair. So if you come over, you can see that this would be -3, -2. So I'm going to do domain, and I'm going to do range. And the domain started with -3. And I'm going to do the range at the same time because I'm looking at ordered pairs, which is an x and a y value. So this would be my x would be -3, that's my domain. If I come down, I see that it is -2 is the y value. All right, so that's the first numbers in the domain and range. The second point is -1, 0. So -1 and 0. The third point would be +1 and 2. And the fourth point would be over 2, 3, over 3 up 4. So +3 and +4. So you can see that your domain is -3, -1, 1, 3. That would be the x values of each point. The range is the y values of each point. So -2, 0, 2, and 4. All right. I'm going to erase that so that we have room to answer B part. B part's going to be written just slightly different. All right, so if you needed to write the ordered pairs before you write the domain and range, that is something that is okay to do. So -3, -2, -1, 0, 1, 2, and 3, 4. So these would be your ordered pairs. And then you simply take your x's, and that becomes your domain. You take your y values, that becomes your range. All right, B part is a little different. So we're going to write domain and range of a line that is continuous. All right, so let's see. We're going to have our domain will be our x's. So let's put x in the middle. And then our domain is going to go from the furthest left x value to the furthest right x value. And it's going to be continuous in between that. So let's see how to write that. So this is -3, so this would be -2. And you can see 0, -1, -2. All right, so let's put -2 here. And then this goes 1, 2, 3, and you can see this is the furthest to the right is +3. And that is a 3 there. Okay, now we need to know that these dots are solid. They're included in the answer, okay? So it's going to be all x's greater than or equal to, and greater than or equal to. All right, so this basically says all your x values between -2 and 3, including those two endpoints, okay? And we do include those because of they are solid or closed in. All right, now your range is very similar, except remember your range is your y values. So put y in the middle here. All right, now the y value, you can see the y-axis goes up and down. X is horizontal, y is vertical. So we're going to go from the lowest y. You can see here's 0. It goes down -1, -2. The lowest this graph goes is at -1. And then you're going to go to the highest point. So you can see it goes up 1, 2. If you come across, you can see 2 is the highest vertical point it goes. And again, it's going to be included because they are solid circles. So that is included in your answer. So your domain is your x's between -2 and 3. Your range is your y values between -1 and 2. So for A part, you can see this is a list of numbers because it's just points on a graph. And B part because it's a continuous line, it has to be written in this form.